Welcome to the Network and Cybersecurity lecture series. Myself, Darshan BD, Assistant Professor, Department of ECE, SJB Institute of Technology, Bangalore. The Network and Cybersecurity subject code is 17EC835. This subject is professional elective for 8th semester students. In this subject, we are going to study the network security concepts and also a cyber security concept. It consists of 5 modules. First 3 modules covers the network security concept and another 2 modules covers the cyber security concept.
Internet protocol traffic processing. In that, IP security is executed on packet by packet basis. When IP security is implemented, each outbound IP packet means outgoing IP packet is processed by IP security logic before the transmission, and each inbound packet, that is receiving packet, is processed by IP security logic after the reception and before passing the packet content onto the next higher layer. Means when you are going to transmit the information or packet, so we are going to the process using IP security logic before the transmission, and so we are going to receive, once we receive the packet, so we are going to apply to the IP security logic, then going to send it into the reception. The flowchart and figure gives that outbound packet. So in that outbound packet, so what we need to do, we consider is, so outbound IP packet means we need to transmit the IP packet, so that we are going to take it from TCP or UDP, transmission control protocol, or user datagram protocol. Search security policy database, we are going to search it in security policy database. So if it is no match found, so no match found means we are going to discard the packet. If the match is happens that, so once it is matches means we are going to determine the policy. So if we are going to bypass means that will goes to the forward packet via internet protocol. So here also once we match found also, so we can discard the packet, that will goes to the discard packet. Here in the determine policy, so we can protect and we can bypass. Okay, once we protect, that means that we are going to search the security association database. So here we are going to take the help of that internet key exchange. The security association database is not found means we are going to help of the internet key exchange, we are going to search it, then we are going to apply the some security association. Then if the match found means we are going to process. In the process means there we are going to consider authentication header and encapsulating security, the payload. So then we are going to pass it to the forward packet via internet protocol IP. So you should understand that. So once that packet is processed using the IP security logic, so if we bypass means directly we are going to transmit. If it is not bypass means we are going to apply the security association. Then we are going to security association means we are going to consider the process of AH and ESP, then authentication and encryption is happens in that authentication header and encapsulating security payload. Then so we are going to send through the internet protocol. Here, so starting itself it's not matched. So we are going to search that particular packet, outbound IP packet, search security policy database, that policy is not found means we are going to discard that particular packet. Okay, there we are going to check the authentication part. So here the consider the steps when you are going to follow that outbound packet. Here the main is we are going to take the data from the higher layer, that is considered as a TCP or UDP then. So first step is IP security, the searches the SPD, security policy database, for a match to this packet. So it's going to check whether it is matching or not. If no match found, no match found means then the packet is discarded and an error message is generated that the packet is not matched, no match found. If a match found, okay, next step that if a match found, further processing is determined by a first matching entry in the match in the security policy database. If the policy for this packet is discard, then the packet is discarded. If the policy is bypass, you can consider here is bypass. This happens that bypass means then there is no further IP security processing. Okay, if it's going to bypass everything, then the packet is forwarded to the network for transmission. Then, so directly it will go for the transmission. It's not considered the any IP security the processing. Next, if the policy is protect, then the search is made security association data for matching entry. If no entry is found, then internet key exchange. So IK is involved to create a security association with the appropriate keys and an entry is made in the security association. If when I am going to consider that to protect, in that the search is happens, if it is not matching means, so in that, so we are going to invoke that internet key exchange, then is going to create the entry there. Then if the match entry is SED determines the processing for this packet, encryption, authentication or both can be performed and either transport or tunnel mode can be used. You know that the two modes of operation, transport mode and tunnel mode, there we can use, okay, so authentication header and encapsulation security the payload. The packet is then forwarded to the network for the transmission. So in the network we are going to use internet protocol to transmit the packet. Here consider the inbound IP packet. So inbound IP packet is from the internet, means that is we are receiving the packet. So outbound we are transmit the packet. Inbound means we are going to receive the packet. So we are going to receive the packet from the internet. So we are going to consider a packet type, whether the packet type is IP or IP security. So here why we are going to consider IP and IP security means in the outbound, suppose the packet is bypasses means is not happen the IP security processing then. So that's why we are considering IP internet protocol or internet protocol security. If the packet is IP, that we are going to search security policy database. If the IP security packet is found, search security association database, then we are going to process this. Here we are going to apply the IPsec logic. You can consider IP security logic. Okay, so first step is if we found IP security, means internet protocol security then. So if the packet is IP security, search security association database. So if no match found means discard the packet. If the match found means we are going to process that. There we are going to do encryption and authentication. So there we are going to use authentication header or encapsulating security payload, that too for transport mode and tunnel mode. Then once the IP security logic is processing is happened, then we are going to send the packet to the IR layer. You can consider as a deliver packet to the IR layer, example TCP and UDP. So suppose the received packet type is internet protocol, then we are going to search a security policy database. If not bypass means we are going to discard, because this is not happens with the security is not processed with the IP security logic. So if it is bypass, once again is bypass means it's going to deliver to the higher layer. If not bypass means the particular packet is we are going to discard it. Okay, this is called as inbound packets. The flow means our operation steps. Okay, so the main elements of IP security processing for inbound traffic. An incoming IP packet triggers the IP security processing. So consider some steps. First one is IP security determines whether this is an unsecured IP packet or one that has ESP or AH header trailer by examining the IP protocol field. Considering IPv version 4 or next header field IPv6 is the first step. So next we are going to consider that if the packet is unsecured, so IP security searches for security policy database for a match to this packet. If the first matching entry has a policy of bypass, the IP header is processed and stripped off and the packet body is delivered to the next higher layer such as TCP. If the first matching entry has a policy or protect or discard, or if there is no matching entry, the packet is discarded. Consider if the packet is secured. If we consider for a secured packet, IP security searches for security policy database. If no match found means the packet will be discarded. If matches happens, IP security applies the appropriate ESP encapsulating security payload or authentication header processing. Then the IP header is processed and stripped off and the packet body is delivered to the next higher layer such as TCP or UDP. Encapsulating security payload. So in that, the encapsulating security payload can be used to provide a confidentiality, data origin authentication, the connectionless integrity, an anti-replay service, and traffic flow confidentiality. So we know that what is authentication, only authorized servers should use that, authorized users. The connectionless integrity, so even if the connectionless, so we need to check that whether the received packet is matched with the sent packet. Next point is the set of services provided depends on the options selected at the time of security association, establishment, and on the location of the implementation in the network topology. Next is the ESP, the encapsulation security payload can work with the variety of encryption and authentication algorithms. ESP format, encapsulating security payload format. Here you can observe that the top level format of ESP packet. So here considering that security parameter index is 32-bit, sequence number will be 32-bit. Then we are going to follow by, we are going to use payload data, that is variable, that can vary the padding, so we can use 256 bytes, that is vary from 0 to 255. So we can use the pad length and you can use next header. So for that we are going to use integrity check value, that is considered as ICV, that is also variable. That so you can observe here the encryption or ICV coverage. So integrity check value is covered all the parts, that is including the security parameter index, the sequence number, the payload and padding part. But the encryption happens only for the data. So whichever the data we are going to use payload and the padding up. For that only we are going to do encryption. But the integrity check value will be happen including the sequence number and including the security parameter index. So the ESP header consists of the following fields. So considering security parameter index, that is 32-bit. Next is sequence number, that is is also 32-bit. Payload data is variable. Padding 256 bits. Pad length is 8 bit. Then is next header is 8 bit. Integrity check value, that is also variable. So first consider the security parameter index is 32-bit that defines a security association. Next, the sequence number is 32-bit. A monotonically increasing the count value. This provides an anti-replay function as discussed for authentication later. The payload data, this is transport level segment, consider as a transport mode or IP packet. Consider a tunnel mode. This is protected by encryption. Padding is 0 to 255 bytes. Pad length is 8 bit. Indicates the number of pad bytes immediately preceding this field. Next header considered as 8 bit. Identifies the type of data contained in the payload data field by identifying the first header in the payload. Next is integrity check value, that is variable. A variable length field that contains the integrity check value computed over the ESP packet minus the authentication. Here considering the substructure of payload data, so in that we are going to consider here the security parameter index is 32-bit, the sequence number is 32-bit. We are going to consider the initialization value IV, that is optional. Then we are going to use the rest of payload data. Payload data will be variable. The TFC padding, that is optional. So traffic flow confidentiality, TFC means traffic flow confidentiality, so that is optional, that is variable. So again same padding we are going to use, same as the ESP header. Here we have 256 bytes of padding we are going to use, 8 bit of pad length, 8 bit of or 8 byte of next header we are going to use. Integrity check value ICV, that is also variable. So here once again that we can check that with the encrypted and ICV coverage. So for the encrypted, so we are going to consider the data, that is considered as the payload and the padding. So it includes the TFC padding also, traffic flow confidentiality, the padding also it's going to add with that. Then so for the ICV coverage, so till all these, the sequence number, integrity, initialization value, security parameter index, all this we are going to include in that. So here two additional fields present compared to the ESP header. Here an initialization value or nonce is present if this is required by the encryption or an authenticated encryption algorithm used for ESP. If the tunnel mode is being used, then IP security implementation may add traffic flow confidentiality, so padding this happens. After the payload data we are going to use TFC, and before the padding field, in between the payload and padding we are going to use traffic flow, the confidentiality. After that the payload data, before that padding field we are going to use the traffic flow confidentiality, the padding. Thank you.